We would probably still be cave dwellers if men and women hadn't learned to communicate with each other. In order to communicate information, you need a language form. It could be tom-tom drums in the jungle, it could be smoke signals, or it might be the kind of finger movements that you help to communicate with the deaf. In my film sequence here, you can see a tic-tac man conveying some very important information, 10 to 1, 7 to 1, the number of a horse, quite complicated information. There's a batsman guiding in a helicopter pilot. I wonder if he's called Robin. Really a very, very important job. Very, very important to have that. And here you see a very intelligent Welsh sheepdog with an even more intelligent farmer, a Welsh farmer, of course. In the Canary Islands, there used to be a whistling language between people, in fact, but there you see a lovely example in the Welsh hills. Of all the language forms that exist, by far the most flexible and expressive is human speech. Over 400 languages have now been identified. English derives from the Greek language, heavily modified by the Romans and other invaders to this shore. The Welsh language is very distinct to English. It has its own alphabet. It's been in literary existence now since the 6th century. Only 500,000 people speak it. It should actually be more for very good technical reasons. Let me tell you why. I have here a very good physics word, quantum. There are 7 letters in this word. But if I peel away that letter, you all know what it is because every Q in the English language is followed by a U. Similarly, I can peel away the last letter because there isn't any other word in the English language that isn't quantum that follows those first 6 letters. So 2 of those letters, 2 of the 7, are redundant. And what that means is that if you want to communicate that word in a noisy room in, say, a busy cocktail party, or send it along a wire, there's far more chance of it being received correctly because more redundancy means there's an error correction basically in there. And you've guessed it, the language that has most redundancy of all the well-known languages is Welsh. There are also computer languages these days that have built-in redundancy. Languages like English and Welsh make us human. Written communication, on the other hand, makes us civilized. Many years ago, the speed with which written communication traveled was very, very slow. Sometimes just the speed of the swiftest horse or perhaps the occasional carrier pigeon. Do you know that when the American colonies declared independence from England in 1776, it took 48 days for that message to be received in London? And so no wonder that people were looking for faster means of sending communication. There was a big advance at the start of last century when semaphore was discovered. Semaphore comes from the Greek for signal displayer. And it was invented by 3 Frenchmen, 3 French brothers. Claude Chap was the eldest, so there were 3 clever chaps who invented this special semaphore system. They told Napoleon about it, and he installed it right through his empire. It really was an excellent means of communication. In Britain, the first semaphore system was used again for defence purposes between the Admiralty and Portsmouth. The fastest speed of communication using that means was about 170 miles per minute, but that's a big advance on the fast horse. The problem with that type of telegraphy is that it's only useful in daylight hours, and even then, only when it's not misty or foggy. Early last century, people started experimenting with electric telegraphs. And I have a beautiful example on my right, which dates from about 1839. Let me tell you about the history of the electric telegraph. It all derives really from a very early observation by Ørsted. In 1819, he showed that if you had a current in a wire, it deflected a compass needle. So he was able to show a relationship between current and magnetism. A Russian diplomat, Baron Schilling, thought, well, this might be a good idea to send information. But he didn't take that idea very far. But an Englishman called Cook thought, well, this really would be a good idea. I can make it commercial. He tried, but he wasn't a scientist, but he knew that Wheatstone was interested in this kind of problem, and the two of them formed a partnership. And in 1837, they were given a patent, the very first patent for the electric telegraph. Wheatstone had come about this type of research in a very roundabout way. His parents were musicians, and he'd been interested in the velocity of sound. Now he became interested in the velocity of this new electric fluid called electricity. And in the basement of where he did his research, he had a coil of wire 4 miles long. Can you imagine that? Where he sent a message along and tried to time how long it took to reach the other end. And in this way, he was able to estimate crudely that the velocity was roughly equal to the velocity of light. And so, as I said, Cook and Wheatstone formed a partnership, and they produced telegraphs of this kind. We call this a 5-needle telegraph. You can see here very clearly 5 distinct needles. They're wired up, and so if I press 2 of these keys, you see these needles deflecting. It's easier for me to explain how this 5-needle telegraph works using the next sequence of slides. Here's the diamond of the telegraph, and here are the 5 needles. Now let's suppose it's the letter F that we want to transmit. Well, these 2 needles will move. You see they're pointing towards that letter F. If it's the letter A that we want to transmit, it's these 2 needles that move. And there they are, they're pointing to the letter A. And in this way, we can build up a word. R, A, D, A, Y, Faraday. I have in front of me here a couple of so-called ABC telegraphs from that period made by Wheatstone's company. And I'd like a couple of assistants to help me. Would you like to come and help? What I'd like you to do is to stand down there by the receiver end. If you just stand there, I'll tell you exactly what to do. And let's see if I can have a volunteer. Would you like to come and help me? Can you squeeze past everybody else? Now, what I want you to do is to help me transmit a message to that young gentleman over there. I'm not going to ask you your name for a very good reason, but we'll ask you what your name is.
Charles.
Hello, Charles. Now, let's pretend you're in a totally different room from us, and this young lady is going to send you a message. And she's going to send you her name. And I want you to write down, as each letter moves there, just what her name is. And let's check if the whole thing is working. Now, what I want you to do is, if this is the first letter of your name, you push that, and then you must turn that handle very quickly. So why don't you do that? If you press the first letter of your name, and then you turn it very quickly. That's it. Good. That's the first letter. Now to the next one. Good. That's your name?
Yes.
Great. Now let's see what your name is.
Her name is Maya.
That's right, I think.
Yes.
Thank you very much indeed. Thank you for your help. That sort of transmission of information is very public. And so one of the first things that Wheatstone did was to invent a cryptograph. And I have an example here of that cryptograph, where now if you wanted, say, to transmit the letter K, what you'd actually do is to send the letter W. So there was a code built into here. The 5-needle telegraph that I've just described to you here was used for the first time along the railway line between Paddington and West Drayton. And this is a section of wood here, which you can see contains 5 wires. And this section of wood was all the way along the line from Paddington to West Drayton, carrying the 5 telegraph wires that actually stimulated these needles on the telegraph. The telegraph became very well known in 1844 because when the second son was born to Queen Victoria, within minutes of the birth, the information arrived in London. The Times published it it was just in time for that evening's publication, and the whole country came to realize just how important the telegraph could be. Another important invention at that time was made by a Welshman called David Hughes. What he worked out was an automatic printing telegraph. So instead of somebody having to wait at the other end, like Charles did just then, you could actually have a printed information waiting for you when you got back to your telegraph. Wheatstone found fame and fortune from his invention. He was charging £4 per mile per year for his telegraph. And his company was nationalised in 1869, so he became a very rich man. He also obtained a knighthood. In this Royal Institution here, about that time, Sir William Preece, who was the chief engineer at the post office, said during a discourse, "I have not the slightest hesitation in saying that our telegraphic apparatus, thanks to Wheatstone, is at the head of the world. There is not a town in the United Kingdom possessing a daily newspaper that is not in direct communication with London for news purposes. And by this means, every man receives at his breakfast table the latest item of news." He added, "My own impression is that the time is not too far distant when even America will take advantage of the inventions we are now using." But America was doing very nicely, thank you, because independently of Wheatstone and Cook, 2 Americans, Morse and Vail, had invented their own telegraph. And that required a slightly different principle. And you're all familiar now with Morse code, where you can send a binary signal. It's a bit like the American smoke signals. It's a binary signal that you can send. Morse was the first to appreciate that you needed some sort of standard code. And what he worked out was a system where the most commonly used letters, like the vowels, E, for example, is a simple dot. 2 dots is the letter I. He was able to derive a standard code which was even used in the Second World War to great effect. What I have in front of me here is a slightly advanced version of Morse's equipment, where instead of the dot dash, you can see here a piece of metal which has grooves in. Where there's a sharp groove, that corresponds to a dot. And when it levels out, that's a dash. And so by moving this along, you can very, very quickly transcribe the information. So this is an advance on the simple Morse transmitter. Morse was given permission to set up his telegraph between Washington and Baltimore. And so America was very soon linked with telegraphy. Because of improvements in insulation of cables, it was then possible to lay cables in the sea. And London and Paris was linked by telegraph in 1852. And more importantly, Wales and Ireland were linked in that same year. England and India were linked in 1864. And 2 years later, the really big one, England was linked to the United States. And the ship that was used to carry out that very difficult task was Brunel's steamship, the important ship called the Great Eastern. So what I've described to you is really the birth of electrical engineering. The profession, the industry of electrical engineering started with the electrical telegraph. Because these pioneers had shown that you could transmit intelligence at the speed of light right across the surface of the Earth. But despite that speed of communication, the electric telegraph had its drawbacks. And that was because of the human interface. You had to give a message to somebody, he would code it, send it one letter at a time, and then decode it. So it really wasn't that swift a means of communication. But about the same time, the second dramatic change in telecommunications last century started. And this was the invention of the telephone. It's a bit like the telegraph, really, in that the real pioneers, those who did the basic science on the telephone, are not really well recognized now. But there was a German called Philipp Reis who, long before the telephone was officially invented, sent musical melodies along a wire. But the person who is credited with inventing the telephone is Alexander Graham Bell. He was a Scotsman. At the age of 23, he emigrated to Canada. And on St. Valentine's Day, 1876, he filed the patent for his telephone. But he was incredibly lucky, because that very same day, an orphan boy called Elisha Gray also filed the patent for the telephone. What people didn't know at that time was that Bell had not in fact transmitted human speech on the telephone. That occurred 1 month later using Elisha Gray's transmitter. So Bell, in my opinion, was rather fortunate to be called the inventor of the telephone. Bell designed various kinds of telephone, and his first was what we now call the butter stamp telephone. That's because in terms of its shape, it's very similar to the wooden instruments they used to use to make imprints in pats of butter. But this was the type of instrument they used. You could speak into it, and you could also listen as well. And if you were wealthy, you had two of them. So you could both speak and listen at the same time. Alongside me here, I've got an upmarket version of the butter stamp telephone. 2 years after his invention, in fact during his honeymoon, Bell visited England. And he had an audience with Queen Victoria. And this was in Osborne House on the Isle of Wight. And this was the telephone that he presented to her. So it's a rather ornate telephone, and it's been loaned to me by the Science Museum. The butter stamp instrument is rather more sophisticated than this one. You see it hangs on a hook, which was a feature of these butter stamp telephones. And the origin of expressions such as, I'm hanging up now, or off the hook, putting the phone off the hook, comes from that period. So those are early examples of Bell telephones. The principle on which they're based was that discovered by Faraday in this Royal Institution here in 1821. What Faraday discovered was that if you have a coil and place it in a magnetic field, so here are the poles of the magnet I have here, and if you move that current in the coil, you induce a current. Now, perhaps somebody would like to help me with this. Would you like to come and help me with this demonstration? What I'd like you to do is to rotate this wheel. And what you'll be doing, you see, is that this wire you'll be moving in this magnetic field, and what that does is to produce a current. And what we should find, if all goes well, is that that bulb will light up. So why not turn it round as fast as you can. There we are. Can you see the light coming on? Excellent. Thank you very much for your help. What Bell had done was to work out his receiver and transmitter this way. He said, let's take some vibrating membrane. And in his case, he just took parchment paper. He said, well, sound signals will vibrate the membrane. If we now attach a piece of iron, and he did that using a clock spring, that piece of iron will oscillate as the sound hits the membrane. And if we position that piece of iron close to the poles of a magnet, we can induce a current. So there'll be an alternating current produced, which will be in harmony with the sound signals. And that was the basis of both his receiver and his transmitter, the earpiece and the mouthpiece. Now that invention is rather good for a receiver, and even modern telephones use that principle. But as a transmitter, it really isn't any good at all. And the person that is responsible for introducing the transmitter or microphone that we have these days is Edison. You've heard about Edison before. In our first lecture, we had him inventing the light bulb, and in the third lecture, the phonograph. Well, here he was now with a major invention. As you know, he'd been working on carbon filaments for light bulbs. What he discovered during the course of these measurements was that if you have some carbon, and if you put pressure on it, its resistance changes. And I'll try and demonstrate that to you now. Here I've shown the resistance of this carbon. I'm now going to turn the needle and put pressure on it, and you can see the resistance decreasing. This was the effect that Edison noticed, and he based his microphone on it. The person who actually fully explained what was going on was David Hughes, the Welshman who'd invented the automatic printing telegraph. And what David Hughes had said was that it's not compressing the carbon that matters, it's the interfaces between tiny pieces of carbon that are there. And he said you'll get a much, much larger signal if you use carbon particles or carbon granules rather than a solid piece of carbon. Now, I have a very simple demonstration here, and I'd like somebody to help me. Would you like to come and help? What's your name?
Emma.
Emma. Now, what I've got here, Emma, if you just come around here, I've got lots of carbon particles. And just to show that they really are fine particles, would you like to pour those into that glass? See, it's very, very fine carbon. That's what I've got there. And before the program, what I did was to put the carbon particles into this microphone here. So that was using Hughes's principle. Now, what I want to do now, seems to be working, doesn't it? Would you like to shout into this Hughes microphone? And shout your name, that would be the best, wouldn't it?
Emma Shanks.
And do you get closer?
Emma Shanks.
Very good, you see? It really does work, doesn't it? That works as a microphone. Thank you very much for helping, Emma. And so modern-day microphones are based on Edison's microphone and on Bell's receiver. And not surprisingly, these two gifted inventors put their heads together and they formed a joint venture. And I have here a telephone from that period made by the Edison Telephone Company. And as you can see, you can speak in here and you can listen here. So that's a very, very old telephone dating from about 1880. It'll surprise some of you to know that George Bernard Shaw once was employed by the Edison Telephone Company. In one of his works, George Bernard Shaw says, "You must not suppose because I am a man of letters that I never tried to earn an honest living." Obviously, being a playwright must have been dishonest. I began trying to commit that sin against my nature when I was 15 and persevered until I was 23. My last attempt was in 1879 when a company was formed in London to exploit an ingenious invention by Mr. Thomas Alva Edison. A much too ingenious invention as it proved. It bellowed your most private communications all over the house instead of whispering them with some sort of discretion. So the telephone was the second of these important breakthroughs in telecommunications last century. The third one was telegraphy without wires, or radio. Radio waves had been predicted theoretically by Maxwell many years previously. But the first practical demonstration of radio waves, believe it or not, was by David Hughes, that same Welshman who invented the automatic printing telegraph and the microphonic effect that I've just described in carbon granules. What he did was to send signals along about 500 yards of Great Portland Street near Regent's Park in 1879. The person who's given the credit for the invention is Heinrich Hertz. In 1888, exactly 1 century ago, using equipment like this, and this is a replica provided for me by the University of Kent, he was able to transmit radio waves. The principle here is that you have a spark generator. This generates a spark here, and that connects the two parts of this dipole. And when that happens, you get charges of opposite sign on these pieces of zinc at opposite ends here, and they oscillate. And using dimensions of about this size, you send off a frequency of about 50 megahertz. So we can honestly say that Hertz was a bright spark. In order to pick up the signal, Hertz required an aerial, a bit like this. So that if you have an aerial of the right dimensions, you could cause oscillations by the free electrons in here corresponding to the frequency of the transmitter. A few years later, and in fact the announcement was made in this Royal Institution here, a person called Oliver Lodge described tuned circuits where you could modify aerials to tune in to particular frequencies. The person we regard as the inventor of genuine commercial radio is Marconi, and in 1901 he sent signals all the way across to America. The Russians disagree with us. May the 7th in Russia is called Radio Day, and that's because they believe that a Russian called Popov invented the radio. The BBC, as I mentioned in a previous lecture, started in 1922, and this meant that modern microphones had to be invented rather better than the ones in a normal telephone. And I have a couple of beautiful examples here of silver microphones, made by the MI company for royalty. Every member of the royal family had their own microphone, which is very, very heavy. It's made of solid silver. This was made for Queen Mary. And the one alongside me here is the one that was reserved for King George V. And on here is inscribed all the various special occasions when he actually used this special microphone. So I've described to you now the three basic telecommunication inventions of last century. Hughes, this famous Welshman, figured in all of them. And he is commemorated, in fact, by the Royal Society of London. A special award is given each year, a very prestigious award, for a person who's done novel work in communications. The consumer had a lot to say, obviously, in inventions like the telegraph and especially the telephone. When you produce something new like a telephone, there's certain resistance to change initially. Charles Priest, who I've quoted earlier, who thought wonderful things of the telegraph, didn't think the telephone was necessary. He said, we have enough messenger boys in this country to send messages around. We don't need the telephone. But as gradual acceptance comes, so technical improvements are made, and that then speeds up the acceptance, and you get a rapid acceptance then. Behind me here, I have some beautiful examples of telephones, which again have come from the Science Museum. And these illustrate really how telephones have changed over the years. This type of telephone here was the very first sold by the post office. The receiver was rather heavy, and it's in this box here, and therefore it was wall-mounted. And so you spoke in here, and you had to listen through these tubes. This one here was made by Ericsson in Sweden, a company that is still in existence. And this was the first telephone to couple together the earpiece and the mouthpiece. Really very nice phone that dates from 1893. This telephone is an interesting beast. It dates from 1905 and is the Strowger telephone, or sometimes called the pot-belly phone for obvious reasons. This was a very, very good invention because, as you can see, it has numerals on here. Strowger was an American undertaker, and he was very, very fed up because telephone operators were sending all the trade to his competitors when people telephoned in. And he invented an automatic switching system which formed the basis of automatic telephone exchanges. And so it's from this period that you see dials like this on the telephone. This example here, you can call the first mobile telephone. It was attached to the trams built in 1901 that went up the Great Orme near Llandudno in North Wales. This is a very, very popular telephone shape. This is the candlestick phone, which was used in the late 20s and the 30s. These days, of course, we have push-button phones like this, but you can now purchase push-button phones virtually the same shape as this old candlestick phone. I have here a very, very interesting little book. It's a very thin book. It's the telephone directory for London for 1880. It's worth looking at, the first page, because it acknowledges the fact that it uses patents by Bell, Edison, and Crossley. Do you know there isn't a single Roberts in this telephone directory? There's only one Jones, and there are 4 Smiths. Most of the companies involved are railway companies, because the telegraph obviously started along railways, and they quickly cottoned on to the use of the telephone as well. Another interesting feature is that the phone numbers are listed numerically. So we have number 1, 2, 3, 4, all the way down. The very first number is Harvey Brand and Company. They had the number 1 in the telephone book. This interesting one here dates from 1899. And it's the telephone directory for all of Britain and all of Ireland, all in that book there. The London section is just that thick. Let me highlight for you one page in here. I'll make a town in Lancashire famous now, Blackburn. The good side is that I'll make you famous. The bad side is that I'll mention the Tottenham beat you in the cup this year. Blackburn has 5 pages in this telephone directory from 1899. In 1988, not only does it have its own telephone directory for the Blackburn area, but in addition, it has its own yellow pages. So things have really moved on dramatically. In the UK now, there are 35 million telephones, and 82% of the households in Britain have a telephone. But of course, it's taken 100 years, more or less, to get us to this stage. Where are we going now with all these wonders in modern electronics? Well, there are many, many interesting developments taking place in telephones. The Japanese now are just about to bring out a scratch pad telephone where, as well as speaking to a person, you can write a little message on a pressure-sensitive pad and send a note as well. Also, there's work going on video telephones where you're combining now TV and telephones. But it'll be some time before that's a commercial reality because of cost and because of the limited bandwidth available. The sound that you hear across a telephone line at the moment isn't very high quality, but moves are afoot to make that hi-fi quality. People's perception now of sound is very different to what it used to be. They have a better understanding of how the brain and the ear work. And so, hopefully before long, we'll be able to improve that quality. And there are all these interactive databases that are available now, like Prestel. Very shortly, Prestel will be bringing out a simple system where you can call in any telephone number in the whole of the UK and Europe. But the dramatic change that has taken place in the last 5 or 6 years is cordless communications. We know now that you can communicate from a car, a moving plane, or from a train. And those of you who've seen the soap opera Bread will be very familiar with simple cordless telephones like this here. This kind of phone, we'll call a CT1 phone, this is a cordless telephone 1 phone, is an analog phone. About 500,000 people in this country now use phones like this. But because a very restricted bandwidth is available, the whole system is reaching saturation. But in 1989, there will be a dramatic change. And we'll be using, instead of this phone, which I'll call a CT1 phone, a much more portable phone called CT2 phone. CT2 phone. Let me explain to you the basic difference between them. I've shown here the electromagnetic spectrum. And the region we're interested in with cordless phones is in the radio microwave region, in this region down here. Now let's just blow up that region there. We're talking about frequencies in the range 10 megahertz to 1,000 megahertz. What has been reserved for the CT2 phone is a special band just about here. There's 4 megahertz of bandwidth being made available between 864 megahertz and 868 megahertz. And that 4 megahertz will be broken down into 40 channels of 100 kilohertz each. And that will give ample scope for more and more people to have access to a cordless phone. So this here is a digital phone. This was an analog phone. The marketeers are predicting that in about 5 years' time, 4 million people in this country will have phones like this. They're also saying that by the end of this century, half the people in Western Europe will have these phones. They only weigh about 4.5 ounces. They'll cost about £150. You also need a base station like this in your home, which costs about the same amount. There are a couple of snags with these existing phones. One is that if you take it out shopping with you or take it to the office, you'll need to be within about 200 meters of a base station like this in order to make a call. But the idea is that there will be thousands of these base stations positioned all through the country. Another disadvantage is that you can only call out with these phones. You can't receive a call, but you could receive a bleep. My prediction, just as I predicted that the incandescent bulb will be replaced almost totally by the fluorescent bulb, and just like other things that I've mentioned to you in the last few lectures about vanishing LPs and so on, I predict that the traditional telephone will vanish in the next 15 years or so, to be replaced by these very, very handy phones that just slip into your pocket. These phones will become as common, I think, as wristwatches. Very, very common. And so, although it took 100 years to get us to where we have been in the last 5 years, the rate of change now is so dramatic, we can expect changes virtually every week, I think, in this fascinating field of cordless telephones. Let me now, for the remainder of my lecture, turn my attention to communications in the home. Communications technology and computer technology, that marriage has already taken place and produced office automation and factory automation. But the next stage will be home automation. Now, what do we mean by home automation? Could it be this?
Are you eating again? No wonder you're getting fat.
Your toast is ready. The kettle has boiled.
There is enough for 2 cups.
2 cups.
The kettle has boiled. The egg whites are stiffly beaten.
The egg whites are stiffly beaten. The oven is still on. The oven is still on. The light is
Please clean.
Please clean. Your toast is ready. Ready?
Remember to lock the door. Remember to lock the door.
You have left the light on.
Thank you.
Now, isn't that horrible? And I can assure you that home automation does not mean what that film clip showed. Home automation is for the benefit of the consumer. The technology is already here. It's the consumer that's pushing and pushing to have it introduced into the home. Because there are 3 major benefits of home automation. One is convenience. The idea that you can communicate from one room to another in the home or from anywhere outside into the home as well. The second is an economical one, to improve energy management in the home. And the third is to give people more peace of mind in terms of security in the home. The thing that distinguishes an ordinary home from a smart or intelligent home is the communications medium inside it. And what I want to explore with you now is different kinds of communications and try and guide you through to what we're likely to have in the home of the future. Many of you will be familiar with this kind of handheld controller, which sends an infrared beam to the television. So I can very easily switch that on and off. But if I put a card in the way, it doesn't work, you see? But that's the way it does. So one of the disadvantages of infrared communication is that the radiation doesn't travel through even a piece of cardboard, let alone a wall between rooms. Another disadvantage is if sunlight is pouring in through the window and introducing some radiation, if I could have some lights on to simulate the radiation. Oh, it's not bright enough. Oh, there we go. It's working, but not very, very efficiently. If you have very bright sunlight, it interferes with an infrared controller like this. Some years ago, televisions used to be controlled not by infrared, but by ultrasonic means. This is one such television set. But you just watch what happens when I jangle these keys. There we are. The ultrasonic sound produced by these jangling keys interferes with that set. The RSPCA were very glad when we got rid of this means because, of course, dogs and animals can hear higher frequencies and it used to disturb them. In previous lectures, I mentioned radio frequencies for cooking, for lighting, and also, as you've just heard, for telephones. Is it possible that we could use radio frequencies in the home? Many of you may already have used radio frequencies in the home using cars like this that can be remotely controlled. I have my own special transmitter here for radio frequencies. I built my own. It's a very, very special transmitter. And I also have my special car as well. As you can see, it's a Volkswagen, but it's not German. It proudly displays the Welsh flag. And what I'd like is an assistant to help me play with this toy. Would you like to help? What's your name?
Chris.
Oh, hello, Chris. Right, now, you're going to have to control my transmitter here. Let me switch it on for you. And that's the control button. So let me just now put the master switch on this. Oops. Oh, that's very clever. You're guiding it very well. Gosh, that's lovely, isn't it? Thank you very much, Chris. Do you know we've been breaking the law? You better get up to your seat before you're arrested. I'll tell you why. The reason we've been breaking the law, Chris, is that the frequencies and the intensities allowed for radio frequency controlled cars are very restricted. And for the purpose of this lecture, I've used a frequency outside the permitted range. The radio frequency band of allowed energies is being clogged up. Everybody wants to use radio frequencies. Although I didn't do it with Chris there, radio frequencies would pass through virtually anything. They certainly would pass through a solid wall. So in a sense, it's a very convenient means of communication to use in the home. But legislation doesn't permit it. Radio frequencies can only be sent at certain particular frequencies for, let's say, the cordless telephone or for other applications. It may be that there will be some reduction in that legislation in due course, but at the moment you just cannot use radio frequencies in the home. You must also remember that more sophisticated communication means like fiber optic communications are ruled out in terms of cost. What we want is a very simple system that we can retrofit into an existing home. One of the systems that we have in a home that I haven't yet mentioned is mains wiring. And let me explain to you now how we can imagine our home of the future being wired up. These orange colors here refer to an infrared sensor in the ceiling of a room. So if I'm sitting in a lounge chair, I can communicate, just like I did with the television, with this sensor in the ceiling. In order now to be able to communicate with appliances throughout the house, I'm going to make use of the mains. And so here I've shown the mains. And every appliance is connected to the mains. And this combination of infrared and mains, the two together, will give me all I need in the automated home. Now, you know how infrared works, but how does mains-borne communication work? Well, this is shown on the next slide. This is the 240 volts of the mains. What we're going to do now is to superimpose a small voltage on top of this mains voltage. Let's look at that in an expanded form. This is my half of a volt I've added to the 240 volts of mains. And as you can see, it's divided up into three parts. The first one here is we call the address code. It's important that the appliance that you're sending it to has a certain address. What you mustn't do is to have the wrong address. The last thing you would want to do, let's say, is to switch on the washing machine next door in mistake if you send in a signal. There's an expression that goes something like, friends may come, but friends may go, but enemies accumulate. So you must be very, very careful not to do things like that. But you see that the address code is a binary code. The second stage here is the message. Switch on the cooker. Put it to 715 degrees or whatever. The third component is the checksum. The mains is a very noisy medium, and it's important when you add a small signal that it doesn't get corrupted. And so what you would do here is something like add a sum, 2 + 2 = 4. And if it isn't 4, it'll ask the message to be transmitted again. In practice, of course, it's a very complicated checksum that is done. And so using this principle, it's possible to send an infrared message remotely from your armchair and then have it sent along the mains to the appropriate appliance. I want to demonstrate mains-borne working to you now. I have here a simple modem that I can plug into any socket here at the RI. Let's suppose that I plug it in there. And I'm going to take a lamp as my example, but in fact this could be any appliance. It could be a dryer or a video recorder. And I'm going to ask somebody to plug it in to one of the sockets up here. I think along here you should find a red socket about halfway along. And again, that could have been any socket in the Royal Institution here. And if I switch on here, what I will have is control over that appliance there, so that I can switch on that light and I can dim it. So that is an illustration of mains-borne communication. I have another example here, and this demonstrates mains-borne in a different mode. 2,000 houses in Milton Keynes at the present time are fitted with meters like this. These are remote meters enabling the electricity board, the water board, the gas board to measure at a distance just what your meter reading is. And so by dialing in here the utility, it could be gas, water, electricity, the consumer at home can also find out how many units he or she has used and what the likely estimate is for the quarter. You can do more than that, though. You can also, by collaborating with these public utility boards, specify that at certain periods when the electricity board finds it hard to meet the demand, that you're quite in agreement with them switching off some of these large energy loads, such as water heating and space heating. So when that light is on, you're quite happy for the electricity board to interrupt your water heating, or similarly, the space heating. And so there's a dialogue now which is possible between you and the public utilities, and that will save you money. What other advantages do we have in the smart home? Well, this is the kind of controller that you will have, the portable controller, and you will be able to control lighting, heating, home entertainment, and so on, using this kind of portable controller. This is just a prototype here. So, for example, you can use your video recorder in this unit here to switch on a television, put a film on in any room in the house. By using the lighting menu here, you can decide what groups of lights you want switched on. If you're reading or watching television or just about to go down the garden path, you'll want different groups of lights on. And so you can do that with this controller here. This controller can memorize all the lighting pattern in the house for a fortnight. And so if you go off on a 2-week holiday, you can fool the burglar by having a lighting sequence that comes on almost as if you were living in the house, and the curtains would open and close in synchronism. So there are many advantages of using this kind of controller. Now let me finish by showing you an important example to do with security. And I'd like somebody who's tall to help me out. Would you, sir, like to come down and help me with this? What I'd like you to do is to stand here and pretend that you're coming into my front outside. You're outside my home. And when I tell you to, I want you to go and knock on the door. And what I'm going to do is to pretend that I'm in my television lounge watching Tottenham beating Arsenal. Thank you. Let's switch on the television now. There's a nice shot there. Now what I'd like you to do is to go and knock on my door. You see the proximity lighting's come on. Immediately that's come on, I can see a picture-in-picture on this television here, which I can blow up to full frame if I want. And now I can see you and I can decide that you're friendly and I'll come and open the door. You'd probably have security cameras like the one that is fitted to this door in other parts of the house. You might want to have it in the nursery so that you can monitor your child while he or she is sleeping and you're watching television. Or you might use it for some perimeter detection as well. Well, today we've talked about various communication technologies. Now let's try and bring it all together. Here I have the cordless phone, the portable phone that you can use to communicate wherever you might be, in the office, in the shops, perhaps on the golf course. And you can communicate directly with virtually any appliance in your home. This phone looks surprisingly like one used in science fiction programs like Star Trek. What do they say on that program? Beam me up, Scotty. Beam me back, Scotty. I haven't finished the program. Let me explain to you exactly how this special screen works, which, just with the throw of a switch, is either transparent or opaque. It's made of glass that contains a special kind of liquid crystal molecule. And so you can use this type of screen for security purposes in an office or perhaps in a vehicle. And I'll be saying a lot more in my lecture tomorrow about liquid crystal materials. But for today, I hope that I've communicated things well with you and that you and I have been on the same wavelength. Thank you very much indeed.